Good morning, class. Happy Friday. Welcome to more four-sided figures today in math. So today we're looking at trapezoids. Okay, so if you have this sheet still, I hope you do, you can cut out this one now, okay? We're going to be using our white trapezoid here to examine some properties about trapezoids. And this is my copy that I've made here. It's not perfect, but this is my trapezoid that I've made. And we're going to have a look at our trapezoid rule, because you'll remember that trapezoids have only one pair of parallel lines, okay? And each pair of angles between two parallel sides add up to 180 degrees, okay? So we can do this. We can demonstrate this by cutting our trapezoid this way, okay? So I'm going to make a little curvy line. And I've cut my trapezoid in half. Okay? So this is how we can see that our rule about the pair of angles between two parallel lines, and our parallel sides are this side and this side, right? And so the pair of angles between the two, so C and D are the pair, and A and B are the pair, add up to 180 degrees. And we can see this because if we flip them upside down, they form a straight line. So right here, sorry, it's a little imperfect, but C and D form a straight line, and if you were to scooch it over, A and B also form a straight line here. Okay, so that is proving our rule that the pair of angles between the parallel line sides adds up to 180 degrees, okay? And so you need to remember that this is not a parallelogram, so B and C don't equal each other. So if I were to take C and try to flip it around in front of B, it doesn't work. Okay, so this is not a parallelogram. So A and D, same thing. It's not going to work. They don't equal each other, not like a parallelogram does. But we still have our rule about the pair of angles between the parallel sides adding up to 180 degrees. Okay, so that is our rule about trapezoids. So let's take a moment and write that down in our notebooks. Okay. So you can continue under the note that you have, and we're going to just call it trapezoid rule, okay, because it's just the one. We only have one rule that we can use for trapezoids, okay, and the rule is each pair, and we can underline, I'm going to underline that, of angles between two parallel sides add up to 180 degrees. Okay? So you have that, of course, on this as well. That's our rule right here. And we can see it demonstrated right here. So these two can pair up to add up to 180, and so can these two. Okay? Be careful. So if you look at this, A and B cannot pair up because they're between the two lines that are not parallel. Okay? So keep in mind which lines are the parallel lines. Okay, and it's only the ones that fit between the two parallel lines that can add up to 180 degrees. Okay, so keep that in mind. And now let's have a look in our textbook. Okay, we are on page 71. All right, and we're going to look at this trapezoid here. This is a trapezoid because the question tells us, but also we know that it's a trapezoid because the only parallel lines are these ones. There's only one set of parallel lines. The other two lines are not parallel, okay? And that's how we know that it is a trapezoid, and because the question tells us, okay? So I've drawn it here on the board for you, and we're gonna apply our rule to it to determine the missing angles. So we have DCB that's missing, and we have ABC that's missing. So we are trying to find angle DCB and angle ABC. Okay? And so, in order to find it, we're going to use our rule that the pair of angles between two parallel sides add up to 180 degrees. Okay? So looking at this, we have to determine where our pairs are. Okay? And so, the textbook actually helps us. It gives us the subtraction right here. But let's think about this for a second. So if our parallel lines are these ones, then it's this angle that's going to pair up with this angle. Okay? Because they're between the two parallel lines. Okay? And in the same way, we have this angle that's going to pair with whatever this angle ends up being, because they're also between the parallel lines. Okay? So make sure, so we can't use this angle to find this angle, or this angle to find this angle. We have to use the pairs that are between the parallel lines. Okay? So let's do some math. Okay? Because we know that it adds up to 180 degrees. So in order to find it, we have to subtract what we know. Okay? So let's start with DCB. So we have ADC. So in order to find DCP, we are going to do 180 minus 120, okay? Because that's what this is worth, which equals 60, okay? So C, DCB equals 60 degrees. All right, so that's this one. Okay, so now let's find ABC. So we have DAC as 50 degrees. So to find ABC, we're going to take 180 minus 50, okay? And that's going to give us 130, okay? So now we have that here, 130 degrees, and we'll write our answer here. All right, so do we see how that works? We pair our angles together between the parallel lines in order to find the unknown angles that we're given, okay? So let's have a look a little bit further in our textbook. We're going to look at question 6 together, okay? We've got 3 trapezoids here that we are going to find the unknown angles for, okay? So A, we can see we've got our parallel lines here, and the pair of angles helpfully have just been labeled as the only 2 angles, right? So these form the pair. And the bottom one is 125 degrees, and so we have to find the other one. So in order to do that, we are going to do 180 minus 125, right? To find the missing angle, which equals 55 degrees. Okay, so A is 55 degrees. Okay, let's look at B. So again, they've shown us the parallel lines with our arrows, okay? And they've given us the pair of angles that are between the 2 parallel sides. Okay, we have 68 degrees and then B. So B, we have to do 180 minus 68. Okay, which is going to give us 112 degrees. All right. Okay, and C is just a little bit trickier because we've been given an isosceles triangle within what is a trapezoid. Okay, so the whole thing is still a trapezoid, but it's cut a little bit into an isosceles triangle as well. Okay, so we have to use what we know about isosceles triangles here as well, because it's asking us to find C. Okay, you see C up here, and the angle that is paired with C is actually this angle. Okay, so we have to find the value of this angle in order to subtract it from 180 for this angle. Okay, and we've been given the little 22 degrees slice here, but we have to get the rest of the angle. So in order to do that, we use our isosceles triangle rule that the 2 angles across from the equal sides, which are these 2 sides, are the same. Okay, and we've been given this 50 degrees. So this little pocket here is also 50 degrees. Okay, and so then the rest of the angle for the trapezoid is 22. So we'll add that together to be 72 degrees. And now we can take that and subtract it from 180, okay? So C is 180 minus 72, okay, which is going to give us 108 degrees, okay? Okay, so when you're working on your workbook, you might have to use your critical thinking skills and apply other rules like we had to here for the isosceles triangle with your trapezoids, okay? But you can do it. All right, and I do have my math Zoom today if you have any questions about this lesson or the 2 previous lessons. But now is your chance to do a little bit of practicing. So please complete workbook exercise 47. And if you have any questions, please pop into our Zoom and we can chat about it, okay? Otherwise, have a good weekend.